Okay, so the next concept inside a CNN which I'm going to discuss with all of you is called as a pooling layer. So let me share my screen quickly. And here, so you must be able to see a pooling, right? So, and you must be able to see this 2 cross 2 and it is trying to give you some sort of a value. As an output value, it is trying to give it to you. So what is the meaning of this pooling? How this pooling is going to happen? So let me just talk about it. As you can see, this entire 2 cross 2 is moving over the entire image, right? I believe it must be visible to all of us, right? So it's moving over the entire image. I'm not able to share this side of my screen, but yeah, so it is trying to move one by one, one by one, one by one, as you can see. And then right, so then it is trying to form some different images. So at here, so we had an input size equal to 60 cross 60, and finally the output that we are able to get is basically a 30 cross 30, which is exactly the half of the previous size, right? So here input size equal to 60 cross 60, and then here we are able to get basically 30 cross 30. So what is the meaning of pooling? Why do we do a pooling over here? What is a different kind of a pooling that we can try to perform inside the images? Each and everything, let me discuss. So here, what we have done, so we have applied a kernel, right? In my previous lecture, so we have applied a kernels, and then we are able to get this entire images. This particular part we are able to get. Now, so first of all, why do we need a pooling? So let's suppose I'm talking about a very, very big dimension of the images, height and width, right? So it's having like 1,000 cross 1,000 height and width kind of a images that we are talking about. So obviously each and every time, so we have to do a calculation with respect to our kernels from our images, and then we have to filter out the like a next image, or we have to talk about the next feature. So every time if image size is going to be very, very high, it is going to be a compute heavy operation, part number one. The second part is that all the image or all the feature that we are trying to extract is not going to play a vital role. So maybe, right, maybe the cup part is going to, or the shape of the cup is going to, a line of the cup is going to play a vital part. But maybe the sets inside this cup, maybe a sets outside this cup, or gradients outside this cups are not going to play a very important part. So in this way, we can try to reduce a size, right? We can try to reduce a size. And this is where again pooling comes into a picture, so which will help you out in terms of retaining a most important features, right? A most important features, and then leaving out all the other features. So it will reduce the size obviously, and it is going to help you out in terms of extracting the most important feature, and eventually that is going to help you out in terms of reducing a computation a lot, and then it is going to even help you out in terms of reducing the overfitting or avoiding the overfitting of the data. So now let's try to understand that how this entire pooling is going to work with respect to this example itself. So let me, I think my screen is visible to all of you. So here I'm going to take this output, the same calculation. So here let me write pooling in CNN. Yeah, pooling in CNN. Now, so I'm going to take the same output, feature output that we have received. So we are going to redraw it. Yeah, so we had 3 cross 3. So here we have -3, 0, 2, and then we have -3, -3, 2, and -3, -1, and then 2. Fine. So this is the output that we have received after applying a very first filter. Now this is a 3 cross 3, which is a very small one. So maybe I can try to apply some sort of a padding on top of it. So some sort of a padding. I think we have already discussed about the padding in my previous lecture. So we are already aware about it. So here I can try to apply maybe one layer of the padding on top of this images. Now this will become this one. So 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I have just padded this 0 across this entire image. Now this will become 5 cross 5. Previously it was 3 cross 3. I have just converted that with the help of padding into a 5 cross 5. Now what pooling will do? So here generally with respect to a pooling, so we try to decide a size of the pooling, and we try to decide basically a strides, right? So we try to decide a size and then we try to decide the stride. So stride means the movement, right? So how many steps we have to move basically from the previous step, how many pixels we have to move, and then we have to decide the pooling. So here, let's suppose I'm going to do a 2 cross 2 pooling, right? I'm going to do basically 2 cross 2 pooling. Now, what is the meaning of 2 cross 2 pooling? So 2 cross 2 simply means that I will be selecting this 2 cross 2. This is 2 cross 2, right? So I will be selecting this 2 cross 2. So what we have? So we have 0, 0 and 0 minus 3. So I'll be selecting this. Fine. I'll be selecting this out of this one. And then let's say that I'm trying to perform a max pool operation. So there is something called as max pooling. There is something called as average pooling. So max pooling means what? So whatever is the maximum pixel value that we have inside this 2 cross 2 we have selected, let's try to select that one. Yeah, let's try to select only that one. So out of this 4 value, what is the maximum value that we have? So out of this 4 value, the maximum value is equals to 0. Yeah, maximum value is equal to 0. So max pool or pool size is basically 2 cross 2. This is the pool that we have created, right? So 2 cross 2 of pool that we are talking about. And out of that, I'm trying to perform the max pooling. If I'm going to talk about the average pooling, if I'm going to perform the average pooling, so what it will do? It will try to take the average of this data. So 0 plus 0 plus 0 plus minus 3 divided by 4. So that will be the final pixel value that we will be able to receive. Now, as our strides is going to be 2, so we will try to move 2 steps, and now we will be selecting this 2 cross 2. Now, what is a maximum out of it? Yeah. So what is the maximum out of it? So here again, maximum is equals to like 2 that we are able to see. Yeah, that we are able to see. Now we don't have a 2 cross 2 further, so we can leave it. Then we are going to again select 2 cross 2. What is the maximum that we have? So with maximum is equal to 0. Then again 2 cross 2 we are going to select what is the maximum that we have. So maximum is equals to 2 that we have over here. Yeah, that we have over here. So this is the final output I will be able to get with stride. Slide is equal to our stride. STRID, stride is equals to 2. Yeah, stride is equal to 2. So in this way, we are trying to reduce a size of the image. So now the size of this image is basically 2 cross 2. Previously it was 5 cross 5. Originally it was 3 cross 3. Now it will become 2 cross 2 for me. Yeah, now it will become 2 cross 2 for me. So which is again like a lesser than the original size of the images. And we are trying to extract only a most dominating data or the maximum data out of this entire image. We can go ahead with the average pooling. So again, we'll do the same thing, 2 cross 2, 2 cross 2, 2 cross 2. And out of this, so we will try to just do the summation of this 2 cross 2 and divided by 4. Simple, right? So 0 plus 0 plus 0 plus 3 minus 3 divided by 4, and that is going to be the value. So here you must be able to observe that yes, we are able to reduce the size. That's completely fine. So we are reducing, we are able to, and I'm not just talking about this only 3 cross 3 or 5 cross 5 kind of image. Just imagine that we have a 1000 cross 1000. So many pixels we have to deal with, right? So we are able to reduce the size. We are able to capture the maximum value, right? Maximum value or maybe the average value. So we are not just, we don't have to go and talk about all the values which is available inside the images. Means we don't have to talk about all the value which is lesser than average or greater than average or lesser than like a max, by the way. We are just talking about the most significant one, the one which is going to form the actual image, the one which is trying to represent the actual image. And eventually we are able to get this as an outcome. So this is called as pooling, guys. And even over here, you will be able to find out the exact same thing. So input was 60 cross 60. We have applied 2 cross 2, 1 by 1 it is going to select, right? So here you must be able to find out that we are talking about a max pooling, and here's output wise, it is going to give me 0.1, right? So we have 4 values out of that. So 0.1, and that 0.1 will become the final value. Fine. So in this way, we are going to perform the maximum pooling so that I can reduce the computation by retaining the original or by retaining the important feature, because at the end of the day, I don't want XYZ. What I want is that the data should represent the entire shape, size, or maybe a line, sets, or gradients of the images. That is the only requirement that we have. And yes, with the help of pooling, we are able to do it. And you can try to apply a pooling even multiple times. That's completely fine, right? And here, so you will be able to see that after applying a pooling, we are able to retain the maximum data. Every layer, right? Every layer, we are able to retain the entire data set. So hope the concept and calculation behind a pooling is completely fine with all of you. So with that, thank you so much everyone. Take care and see you again in my next lecture.